Okay, so for this week's demo lab, you have the assignment instructions here and the syntax here. So here's the assignment instructions, and here's my syntax file. This is a different syntax file than last week. Sorry, just instructions. Okay, it says open the files you need. So this is the same data set and codebook that you used for the demo lab last week. If you already have them downloaded open, that's fine. Just make sure you're using the GSS 2022 ones. If not, you can go back to here and download them. Again, these are for the demo lab. This is for the independent lab. So here is my code book, and here's my data set opened. Okay, so now let's see, it says making sure output will display your syntax commands in the log, turn on waiting, then generate the median, mean, standard deviation, minimum, and maximum for theism. Okay, so that's the variable that we used for the demo lab last week. We're going to continue going with it. Share your syntax and output. Okay, so I'm going to make sure my syntax commands show in the log. So I'm just clicking play on this line. I'm going to wait by my wait variable. I need to use the wait variable, not a different variable. The name of the wait variable here is just wait variable. So I'm replacing wait variable name with the name of it. Clicking play. And then here, this is going to run these statistics for me, and I'm doing the theism variable and clicking play. So I go edit, options, viewer, and make sure this is clicked and click OK. For waiting, I'd go data, wait cases. I'd find my wait variable, put in here and click OK. For frequencies, I go analyze, descriptives, frequencies. And I'm gonna find my theism one. Oh, actually that was the what were you doing this? Yeah, this is theism. Put it in here. For statistics, I want to say I want mean, median, standard deviation, minimum, and maximum. And I don't need a frequency table. Okay, so here's what I got for my output. So I'm gonna copy my syntax. And then I'm going to copy my output. Let's take a screenshot of it. Okay. One way to determine outliers is see if they are more than 3 standard deviations away from the mean. What values are 3 standard deviations below and above my mean? Okay, let's see. My mean is 4.68, and the standard deviation is 1.656. So I could do this a couple ways. I could say the mean plus 3 times my standard deviation will give me the value for when z equals 3, right? Like for 3 standard deviations above. And I can do the same thing, like, and just subtract that. So that's kind of the more algebraic way. So I could do 4.68 plus 1.656 times, well, 3 times that. Sorry, minus here and plus there. And I could figure that out. Or again, we can think about, what does this mean? Z equals -3. I can set this up. When z equals 0, that's 0 standard deviations away from the mean. So I'm at my mean. So I'm at 4.68. So if I'm going over to z equals 1, I have to do 4.68 plus, let's just round this to 1.66. And I can just use a calculator for that. So 4.68 plus 1.66 is 6.34. If I want to go one more standard deviation, I'm just going to add that 1.66 again. So 6.34 plus 1.66 is 8. And then I could just add it again. And so 3 standard deviations above is 9.66. Let's check and make sure I got that right. If I plug this in, 9.66. Yep. And again, I can do the same thing in the other direction. So I have my mean. I'm going down 1 standard deviation. So 1 standard deviation below. So that's 4.68 minus 1.66. Then subtract it again to get to below. So 3.02 minus 1.66 is 1.36. And to get one more below, I'll do 1.36 minus 1.66. I get negative 0.3. And let's just check my work with that math calculation as well. 4.68 minus 3 times 1.656 is negative 0.288. Yeah. Okay, so those are the same thing. Let me just clean that up. So either of these would be showing my work. Okay, and so my answer is negative 0.3 and 9.66. So were there respondents below or above these values? So we know for theism that it went from 1 to 6. And so we know nobody can actually be below negative 0.3, right? They can't be that low. And also we know nobody can be above 9.66. So we just know on its surface that there's no respondents below or above these values because they weren't options. However, the way we would do this normally, right, if these fell within the bounds of where people could have answered, is we can look here at the minimum and maximum. And can we see that the lowest the respondent was at was 1, right? I don't believe in God. And the highest was a 6. I know God exists with no doubts. And we can see that so the lowest would be a 1, which is like here, and a 6, which is like here. And so there were not any respondents above or below those. So no, the minimum and maximum were 1 and 6, and no 0.3 and 9.66 fall outside those bounds. So again, this is a way, just like we looked at last week with the box plot, of saying that there are no extreme values responded to had kind of answers that were markedly different from the general distribution of where folks are. We could look at another one and see maybe if we do have one. So let's say that I ran, let's take hours usual. So how many hours do you usually work at all jobs in a week? So let's see what happens if I run that. So here we can see that the minimum is 1 and the maximum is 80. And so our standard deviation is 12.7, our mean's 41. So 3 above would be like about 42 plus 13 plus 13 plus 13, 42 plus 39. So that's over 80. and then 42 minus like 39. Let's see, is around 3. Let's calculate that out actually then. 41.67. So minus 12.72, minus 12.72, minus 12.72. So if we've gone down 3 standard deviations, yeah, we're at 3.51. So we can tell that there's at least one person who responded they worked 1 hour, they usually work 1 hour a week. And so there is at least one respondent who would be a low outlier, right? Because we know there's at least one person at 1 hour, and when z equals -3, we're at 3.5 hours. Okay. Interpret the mean in its real life context. Tell its story. So again, we know that our mean is 4.68. And the question is, what does that actually tell us? Right? What is its story? Okay, so in the textbook, here is a template for interpreting the mean, as well as a couple examples. And so I'm saying the average belief among US adult respondents, right, is 4.7. If you took everyone's levels of theism, right, who is a US adult respondent, right, and let's just say, so if we took every respondent's levels of theism and redistributed them equally, each person would have 4.68. Okay, so that still doesn't tell me anything, right? I don't know what this means. And so I need to look back at that code book to see what it means. So a 4 is sometimes you believe in God, sometimes not. And a 5 is believing in God with doubts. This is a little bit over halfway towards this. So it's somewhere between, so the average belief among US adult respondents is somewhere between sometimes believing in God and believing in God with doubts. And then if you took everyone's respondents' level of theism and redistributed, each person would be right at that thing of like between sometimes and yes with doubts. This is why people like to have ratio level ones where there's equal distance, right? Because we're assuming that we can average these out in that way. You get a much clearer one when you use an actual ratio level variable. So for example, if we took our output from hours usually worked, and we took this mean of 42 hours, let's say 41.67, and you use this template, you could say, right, the average number of hours usually worked in a week for US adult respondents is 42. So I would say, right, it's 42 hours. If you took the total number, everyone's hours in the sample, right, the everyone in the sample, and you said how many hours did they work and redistribute it, then each person would be working 42 hours. I notice here that a lot of the cases are missing, which means we probably don't have good data for this for some strange reason. Let's check instead of hours usual then, because I don't, that's a little fishy to me. Let's try hours last week instead and see if that has less missing data. Yeah, that looks a lot better. So now we have most of it, most of the cases. Okay, so here we'd say, right, that the average number of hours a respondent worked was like 40.5 hours. So if you gathered all the hours everyone worked, like people who worked 0 hours, people who worked 89 hours, people who worked 60 hours, and you add up all those hours and redistribute them so every respondent works the same number of hours, you'd end up with each respondent, every respondent working 40.5 hours a week. Okay, so that's what the average is, that redistribution. Okay, so is my mean value greater than, less than, or equal to the median in general? Let's see. So my mean was 4.68 and my median was 5. So those are pretty close, but the median is slightly less than the mean. right? The mean is, sorry, the median's higher. Median's at 5. Let's try that again. Okay, so the mean is slightly lower than the median. Right. So what does this imply in real life context? Again, the median, we don't care about whether or not there's extreme values, because if you think about it, you're just finding the number where half of the respondents are edit or higher and half are edit or lower. So we're just going to cross out the ones on the end, and it doesn't matter, whether the 50% of people are at 5 or higher, if they're all at 5, if if half of them are at 5 and half are at 6. We don't care about for the half lower, whether they're all at 5, whether they're all at 1, and one of them is at 5, right? It doesn't matter to us in that. And so for the mean, though, we're taking everybody's theistic beliefs, right? And we're redistributing them. And so that's going to take into account extreme values. So if the mean is lower, that means that there are some values on the bottom end, on the lower end, that are pulling the mean down, whereas they're not pulling the median down since they just get crossed out. So it's not kind of an equal distribution in that way. And so if we look at our data set, we can see that the lower ones are not having belief in God. And so there are likely a small number or proportion of respondents who are atheists or have strong views, um, have strong non-theistic views, right? So some folks, there's a smaller group of here, some more extreme cases that are pulling that mean down, but for the median, they're just crossing it out, right? So the median is centered here. We're saying it's not equally distributed going up and down. There's some folks over here that are pulling it down, but a smaller group. If we looked at this one, we could see that the mean's slightly higher. So again, we're saying that there's probably a few people who are working a good number of additional hours comparatively. Um, you can see, right, that like these folks up here, right, are likely kind of outliers versus these. And so that's drawing up the mean. Okay, so do you think that the mean or median gives a more useful average? So this is one that is up to you to interpret, and as long as you're justifying your answer, either would be right. So we could say, I think the mean gives a more useful average because it takes into account every respondent's theistic beliefs and thus also includes more extreme responses. We could say, I think the median gives a more useful average because it represents a more typical theistic belief, a more typical respondent in terms of their theism. Or you could say something like, I'm not sure, right? Mean and median are both useful, right? Maybe you think we should use both, right? Because they tell you different things. As the mean gives us this and the median does that, right? So that's up to you kind of how you decide to interpret that question. Okay, interpret the standard deviation in its real life context. So our standard deviation was 1.66. And so if I go back to my template, here we go. So how much variation was there? So this is the measure of like how far kind of on average a respondent is from the mean. So if the mean is around here, 4.68, we're saying the average respondent is about 1.66. Obviously, it's not necessarily equally balanced here, where it's not necessarily normally distributed, but so that would be around like 6.4, like 6.4, and which it can't get up past six, we know, and then like three. And so we're saying that kind of the typical respondent's going to be in this area. So between in terms of distance. So again, because an average, it's not, they don't have to be equal here, but so if I just were to say this, it would be between like higher power, but not God to, right, like definitely exists and even a little higher than that, right? So I would say that that's a little bit of variation, right? It's not like a lot of variation where like the typical respondent is either not believing in God or definitely believing, right? It's still in this range of like some type of belief. But it's not huge, but it's not so narrow that like if the standard deviation was like zero point 0.2, right? When we say, oh, the typical respondent is basically at this spot, right? They're like there to there. They're not as widespread as we're seeing. We're seeing that the spread is um with 1.66, that's like almost 3.4 if you go in both directions, and this is out of six. So that's like over half the spread of this that it's going. So I would say that there was some variation among respondents in terms of their theistic beliefs. The average respondent had an average deviation of about 1.7 from the mean value of from the mean of 5, 4.7, sorry, 4.7. Oh, that makes sense. Sorry, I made a mistake here. The mean was, no, see, the mean is lower. And so the extreme cases are not the ones that have complete belief, that in terms of respondents who don't believe in God, right? It's going to be the lower ones. So that's down here. Okay. So if we were doing something like this for hours usually worked, you can see, or hours worked per week, you can see the standard deviation is 14 hours. So we're saying the average distance from the 40 hours worked is about 14. So let's say like, if I were to picture that, like a 26 or a 44. Um, and so that's kind of the typical average distance. But and so that would also be some variation. Um, but we would be able to just write that. We could say the average deviation of about 14 hours from a mean of 40.5 hours. For this doesn't make a lot of sense when we try and just tell this story. So um, this is going to be a little bit more difficult to explain. And so the way I'm going to do it is just explain what this is on a 1 to 6 scale, where 1 is atheism and 6 is um, unquestioning belief in God. Okay. 7, choose a categorical variable to use to break down theism by. So why don't we see if the average beliefs vary by education. Let's use degree. It says 2 to 5. So I could do just yes or no for college degree, or I could do this one that's going to have more. Um, I'll do I'll do this one. So I'm going to do just degree, not college degree. I'm going to do degree. So these 5 categories. And so here I'm going to run a frequency table and share my syntax and output. So I'm just putting in the name of the variable here. Click and play. And then for a frequency table, I want to make sure that this is checked. And I mean, I can run these, it doesn't matter, but if I uncheck them, it'll just give me the frequency table without those. And I'll copy that syntax. And I'll take a screenshot of my table. Okay. Explain the story of your frequency table using real life context. So here I'm just saying, look at this valid percent column. So out of the 3,544 respondents, a bit over 1/10 don't have a high school degree. Almost half have a high school degree as their highest degree. Almost 1/10 have an associate's degree. Almost 1/5 have a bachelor's degree. And just over 1/10 have a graduate degree. Okay. So now I'm going to take these, but this time I'm going to break it down by different degrees. And so this is where I'm going to put for my primary variable name is still theism, but then my categorical one, I'm going to use degree. And you can see first, if I just did this college degree, right, in the two categories, it's a little easier. You can think about that when you're doing yours, because I just have, do you have a college degree or not? And I'm comparing my two means. But I'm going to do all five. And then finally for this one, examine is explore. And I'm putting my primary variable where it says dependent list. And I'm putting my categorical variable that I'm breaking it up by into the factor list. So I'm putting in my syntax. And I'm putting in my output. Now this output's really big. What I'm going to do is I'm going to double click on this. And when I do, a new window pops up. And I just want to compare my means and standard deviation. So I'm going to erase the rest. So I'm highlighting them. And then I'm right clicking and clicking delete. And you can see that that way I can get rid of the rest of this stuff and it's going to make it a lot easier for me to compare. And I'm just X out and you can see it auto updates here. So now I have this nice little one that's a lot easier to look at. And so it says compare and contrast our averages for this using real life context. So we can see that less than high school, you're at like a 5, which let me bring up my code book again. So at doubts but believing in God on average. High school, you're getting a little lower. Associate's junior back at a 5. Bachelor's, you're closer to a 4. And graduate, you're a little closer to the 4. So everyone's kind of in this area. But we can find that those who have less than a high school degree, respondents, are slightly more theistic, right? They're higher. On average, believing in God, though with doubts. As education increases, right? As degree increases to go up, we're seeing this go down a little bit such that, or I guess the big difference is probably all of these are closer to that, and then these are closer to that. So let's say those with a college or graduate degree, sorry, bachelor's or graduate degree, are slightly less theistic, um, closer to believing in God sometimes, but not always. Um, and high school and associate's degree are engaging. Respondents with high school and associate's degrees are on average in between. So again, there's not too much difference, but we can see that there is some, right? And that folks with less education are a bit more theistic, although they're all again in this kind of 4 to 5 range. When we look at the standard deviations, 1.5, 1.6, 1.5, 1.7, 1.7, we can see that they're pretty close, right? Again, these ones have slightly more variation. So folks are not quite as uniform. There's a little bit more difference in terms of where people are from that mean. But in general, the standard deviations are pretty close. So I would say that the level of variation of the average respondent from the rest of their degree counterparts. The rest of the respondents with the same degree status is pretty consistent across all educational groups. If I want, I could add, I think that would be fine, but I could add there is slightly more uniformity in belief among those with less education. If we were to look at this and do the hours instead, then we'd see, right, 39, 40, 41, 41, 42. So again, there's a range from 39 to 42. So it's only like 3 hours difference in terms of average, although averages, if you think about how many people have a graduate degree, how many people don't have a high school degree, like that's lots of people. And so those averages do add up in terms of the total number of hours worked and might not be evenly distributed among those groups. But we can see that there's only a 3 hour difference in the averages, but as education goes up, they're working slightly more hours on average per week. If we look at our standard deviations, 17, 15, 13, 12, and 12, those are decreasing. So there's more variation in terms of number of hours worked among those with less than high school and less variation, more uniformity among those with a graduate degree.